Hi all, I welcome everyone to this Preeti Parthiban Gallery YouTube channel. So for today's session, we are going to see how current is going to be equated in JFET. Okay, JFET is Junction Field Effect Transistor. Okay, I've put the full derivation in this. I will just explain you. If you have any doubts, you can put it in the comment section. So this is the first equation, ID equal to IDSS open bracket 1 minus VGS by VP the whole square. So mark this as your first equation. Okay, this is your basic drain current equation. Okay, so here this ID is nothing but your drain current. Your ID is your drain current, whereas your IDSS is your maximum current. Okay, IDSS is nothing but your maximum current, maximum drain current. And this VGS is voltage between gate and source. And this VP is nothing but pinch off voltage. Okay, so this is the diagram of your transfer characteristics in JFET. Okay, so in transfer characteristics of JFET, the characteristics will be of non-linear type. Okay, it will be of non-linear type. So non-linear, here a question rise, why it is not linear and why it is non-linear? So why? Because the non-linear characteristics of a JFET comes because of the pinch off voltage. For example, this is what the drain current, okay, drain characteristics. In drain characteristics, we will be getting the waves like this. I've explained this in another video. I hope everybody know the drain characteristics. Okay, so in drain characteristics, my pinch of voltage VP will be obtaining before itself. Okay, my pinch of voltage will be obtaining before itself when my VGS is negative. Okay, so this you would have learned in the drain characteristics. Okay, so therefore you can see that my value will be, it will be coming like 2, okay, 4, and if it is 1 it will be coming like this, and my pinch of voltage it will be occurred here, so it will be forming like a channel like this. So that's what I've shown it like this direction. Okay, okay, that is what I've shown it like this. So in JFET, okay, the JFET will be of non-linear in transfer characteristics. This is what the diagram mentioned here. The next step is, so what I'm going to do, I have taken my drain current equation as ID equal to IDSS 1 minus VGS by VP the whole square. So my first step is, I'm going to differentiate this with respect to VGS. Okay, I'm going to differentiate this with respect to VGS. So therefore, the first equation becomes ID by VGS is equal to IDSS. Okay, when I differentiate this term, I will be getting 2 open bracket 1 minus VGS by VP. Okay, so I'm differentiating it with respect to VGS, right? So I will be getting 1 by VP. So mark that as equation number 2. Fine. So I hope that you everybody know this ID by VGS. Okay, this term ID by VGS is nothing but your GM. So GM means it's nothing but transconductance. Okay, GM is nothing but the transconductance. That is your drain current by the voltage between gate and source. This is called as GM. Your GM is nothing but your transconductance. Okay, so I'm just converting this ID by VGS into GM. That is equal to, here the next step what happens, minus 2. This value is there, no? Excuse me. So this value is there, no? 2 IDS by VP. Okay, it comes like this. So minus 2 IDSS by VP, open bracket, this remaining terms comes here. 1 minus VGS by VP. So mark this equation as equation number 3. So the next step is, So from equation 1, you can see this is the equation 1. From equation 1, I'm getting, I want 1 minus VGS by VP. So why I am finding this 1 minus VGS by VP means I have to substitute in this place. You can see, right? 1 minus VGS by VP. I am going to substitute that term in this place. So I want 1 minus VGS by VP. From equation 1 I am getting, so what happens? 1 minus VGS by VP is equal to, since it is of whole square, I will be getting root of ID by IDSS. So mark that as equation number 4. Now I am going to substitute my equation number 4 in equation number 3. Okay, that is your transconductance equation. So now what I'm going to do, suppose Gm is equal to Gm naught. I'm going to change my Gm to Gm naught. When my VGS is equal to 0, then the equation 5 will become as, that is, my ID will change into IDSS. Okay, so now I'm going to substitute these terms in this equation number 5. So Gm, I'm changing it to Gm naught, that is equal to minus 2. So in this, I'm going to substitute my ID as IDSS. So when I substitute in this root IDSS, what happens? Root IDSS into root IDSS changes to IDSS. So that's what it is coming like this by VP. So mark this as equation number 6. Okay. Now I'm going to substitute this equation number 6, this particular equation number 6 in equation number 3. I hope now you can understand why we have found Gm naught. So this particular value is there, right? This particular value, it is there in, okay, it is there in my Gm. Now I'm going to substitute that. So that's what happened here. So Gm is equal to Gm naught. Okay, I've substituted my Gm naught value in the place of minus 2 IDSS by VP, and remaining thing 1 minus VGS by VP is coming. So I've marked it as equation number 7. So now Gm is equal to, okay, so till this equation is over. So next I'm moving on to Gm is equal to, just consider equation number 5 again. Okay, so Gm is equal to minus 2 root of Im value comes like this. Okay, so now what I'm going to do, so in this what happens, Gm is nothing but ID by VGS. Okay, ID is nothing but VGS, that is equal to minus 2 root of, I'm changing ID into IDSS and another IDSS, okay, divided by VP. So now this equation will be changing like ID by VGS is equal to minus 2 IDSS by V. Okay, by VP. So now I'm changing this into IDSS by VP by minus 2. Okay, so this VP minus 2, this term is nothing but it will be acting like an intercept. Okay, so this VP minus 2, this VP minus 2 will be acting like a, VP by minus 2 will be acting like a intercept value in my transfer characteristics. Okay, so and the last thing is just for your knowledge, ID equal to IDSS open bracket 1 minus VGS by VGS off. Okay, so this VGS off, it is nothing but, okay, this VGS off, it is also called as VP. So when your VP is there, it is nothing but your VGS, that is the gate source voltage, will be in off condition. So we can change this VP value into VGS off also. So this is what your drain current equation. Okay, so actually this is an important 6 or 7 marks question. It will be asked in your university exam. So if you have any doubts, please put it in the comment section. And if you like this video, just click a like button and subscribe my channel. Thank you.